Thanks for everybody that was here on time. I'm Ido with lakeFS. I run customer success. With me is Amit. Hi, Amit.
Hey, Ido. Good morning and hello everyone on the webinar.
Yeah, good morning, good afternoon for whoever it's relevant. We're here today to talk about troubleshooting and producing data with Apache Airflow. So, without further ado, let's begin. Why do we love Airflow in general? And we do love Airflow a lot. It's because we have, over the years, we've been able to run a lot more complicated ETLs than what we historically could have. So if historically we just ran a simple ETL with tools like Airflow, we're able to do things that are a lot more complicated. And these are some screenshots of some ETLs. Actually, some of our users shared with us pictures that are a lot smaller than this. It goes way out of hand very quickly. And then the challenges and what we're about to speak about today is what happens when this step over here fails. And we don't know exactly how to solve it and what happened and how to troubleshoot it. And that's what we're here to speak about today, alongside with a lot of other cool things that we can do together with lakeFS and Airflow. But Amit, I don't want to embarrass you, but you've been doing this data engineering stuff for a while now. So why don't you walk me through this? This failed. I'm getting an error. What do I do to try and troubleshoot this today?
Yeah, first thing, normally I'll check the logs file and see if there any error message, which is a kind of obvious to understand. If not, I'll start looking into identifying the issue and traverse back and look at the data lineage, like how data is evolving from one task to another, and try to troubleshoot and then fix the problem and then rerun my ETL job again and hope and pray that everything will go fine. So that's the kind of traditional approach we have seen in the past.
Yeah, sounds fun and easy.
Yeah,
it is, right? What we see is when something fails, I mean, it's amazing that we have this visibility, but typically what it means that I want to go and I'm going to maybe start over. Maybe I want to undo all the changes that happened until now. Did I run this in isolation? What their impact on the rest of the data? These are all very complicated things to do. And that's where lakeFS comes into play. Before I actually go and talk about lakeFS, I have a quick question from the people here, which is, have you heard of lakeFS before? So we're just going to bring that question up very quickly in front of you now, I hope, right? I hope that you have the poll in front of you. And if not, you'll probably have it in a few seconds. Amit, we're good with that? Yeah, yes. So we just want to know if you heard of lakeFS in general more than it's Git for data, so we'll know how much to go or not go in details into this as you guys follow this. So thank you for helping with that, and we'll adjust accordingly in our demo here today. But in a very high level, for anybody that heard of lakeFS or didn't hear about lakeFS, what it allows us is a way to manage data the same way as we manage code. So lakeFS sits on top of an object store, right? If that's Google Storage, Azure, Blob, AWS, Min.io, any type of object store, and provides Git-like capabilities through an API for that object store. So it's a way to manage the data the same way as we manage code. So the ecosystem of tools that we have running in our environment can, instead of access the object store directly, which they still can access it through lakeFS and get those versioning capabilities. So to make the integration very simple, and it's something that you can spin up in 10, 20 minutes, the only difference is if before we were accessing a collection and a bucket, now we will access a name of a branch or a commit identifier. A name of a branch will be production, test, development, or an ETL execution. We'll go there shortly. A commit identifier will be a step alongside an ETL execution, or maybe production yesterday at 5 p.m. before the ETL ran, or production yesterday at 10 p.m. after the ETL finished, right? So this will be capabilities once we introduce lakeFS, and then the Git actions themselves, such as commit or branch or merge, can be done through an API or through a command line interface, or through Python, for example. So in the examples that we will review today, you will see ways to execute an ETL in Apache, and then throughout the steps, for example, run commit messages, saving the state of the data, and these are zero clone copies of the data. And then we'll show you how that integrates and plays together. So that's lakeFS in a very, very high level. And we want to jump very quickly to a demo, and let me walk you through what it is, the environment that we're going to demo you today. So first of all, we have a lakeFS server. You have many ways to run lakeFS servers. You can run it locally with a single command. You can see that on our website. We have a playground environment where you will go to demo.lakefs.io, and that will just spin up a lakeFS environment for you that has, buckets with some data in it, and you can integrate against it, and you can run things against it as much as you want. Or you can also run a lakeFS environment on lakeFS Cloud, which is our hosted solution, and there's no commitment there. Also, you can get a 30 days no commitment lakeFS environment to play with a new environment. So literally, you can choose any one of those environments to run lakeFS. In the demo today, I think we're running some of it locally and some of it not, but it's really transparent, and you really don't care. And then the second part of it, which is what we're going to show you a lot here today, is we have some sample repositories. We have a Docker environment that encapsulates within itself Spark and Airflow and Jupyter and some other things, by the way, like Delta Lakes and things like that, which is available here on this link. We're basically going to run this single container, point it to the lakeFS server, and then we're going to look at a few notebooks inside this Jupyter notebook, which are working with existing DAGs, with new DAGs. We're working with hooks, and we'll talk about these in more details in a second. Now, for the sake of time, we're not going to do the entire click-through of everything here, although honestly, if you go here, it's really straightforward. But moreover, we've done this in a previous webinar. So if anybody wants to see the actual demo setup from start to finish with all the clicks, setting it up, downloading the Docker, and so on and so forth, we have this previous webinar here with the Airflow demo setup, and you're very welcome to see that step by step. We want to focus this one on actually the usage of lakeFS with Airflow and not the setup, but again, it's available for you here as well. I want to pause. We have a lot of people that joined over the last 2 minutes. So for those of you who joined lately, just so you know, we're doing this webinar. You're on mute. If you have any questions, please feel free to go on the Q&A button and ask those questions. You can ask them anonymously or ask them together with your name for the people that joined in the last couple of minutes after we reviewed this already. So this is the environment that we're going to show you here today. We're going to have a lakeFS demo. We're going to have a lakeFS server, sorry. We're going to have a sample repository with Jupyter notebooks, with a few notebooks that we're going to present different things. What are those different things? So we're going to go from simple to more complicated. We're probably going to spend more time on the first two, and then just overview on the last two, even though the notebooks are there and they're available for you as a reference. We're going to start with the most basic environment, which is I already have Airflow, I have DAGs running into it, and I want to integrate data version control together with my existing Airflow DAGs. And what we're going to show there, and Amit will talk about it in more details, is the ability to branch out, run an Airflow DAG, and merge the results back in. That gives you atomic promotion of the changes that the DAG did into production. So it's all or nothing, right? If a DAG fails midway, there's no implications on it. You can, and even if it didn't fail and you think that something was wrong in that DAG, you can easily roll back atomically your entire data lake to before that DAG ran. So that's the very first use case that we're going to work on, that we're going to present to you. Then the second use case is even more advanced, which is we're also going to branch out, but we're going to run commits on different branches throughout the execution of the DAG. That's super powerful. That means that we can go and see the data lineage throughout the DAG itself. Again, we'll talk about this in a little bit more details during the demo. Then we're going to talk about some more advanced, I think very powerful use cases. For example, automatically using lakeFS hooks, which are abilities to execute Airflow DAGs. Amit is going to talk about it literally in the next Slack. For example, to validate data before we expose it into production. So we'll ingest the data in one branch, we'll run some sort of Airflow DAG on it, and if everything is okay, we'll promote that to production. And finally, we'll talk about ways to code version version the code alongside of the data, which means that you can now connect the execution of a DAG with the specific version of a DAG with a specific version of the data. This is very, very powerful for many use cases, machine learning or ops specifically, but not only. And we'll walk through these. So with this, Amit, do you want to talk about the integration of lakeFS with Airflow and what makes Airflow powerful together with lakeFS?
Yes, thank you, Ido. So Ido talked about the 4 use cases that we are going to discuss today, or are going to present today. But before I go into more details on those 4 use cases, I want to mention one thing that lakeFS provides different, there are different types of operators or providers available in Airflow. So similarly, lakeFS also provides our operators for Airflow, which makes the life very easy to integrate lakeFS with Airflow, so you can do the version control your data while running your DAG or Airflow DAGs. So some of the things, the operators that we provide is like creating the branch, upload the object, get the object, like pull the object from the repository, and commit your data changes, get the commit details, merge your changes from your development or the ingestion environment to your production data set. So all those operators are available, provided by us. That makes life easier. If you are using operators or Airflow operators, you are familiar with that, the advantage that they provide. And then we also provide sensors along with that. Like when you commit some changes, you commit your data changes, then it will be sensing for any commit happening. As soon as the commit happens, then you can trigger another DAG, or you can do some other task based on those sense when the commit is done. Same with the file. When you upload a data file and you are sensing that data file, as soon as the file is uploaded, then you can do certain tasks. For example, you can do a data quality checks and utilize the hooks to interface with lakeFS servers. Like if you want to do certain tasks which are not available through these operators or these sensors, you can use the lakeFS hooks to interact with lakeFS server. And also, if you want to use, you can use our Python API also. If you just want to use just the Python API without using the operators, you are free to do that too. So we provide a Python API package where you can create a Python client and directly integrate from your interface from your DAG to a lakeFS server. So those are different options. You integrate lakeFS with Airflow for version control. So you can run your DAG in isolation without impacting your production data. Let's go next. Okay, so let me start sharing. So I will go back and forth between different use cases and also demo a different use case. But before
maybe a second before, yeah.
Okay.
I think you're about to ask about exactly. Thank you, bud.
So yeah, just go ahead and answer this question. So this will help us to tailor the presentation. If you are familiar with Airflow, then accordingly, I will go into more in-depth in the demo, or I will stay at the higher level if people are not familiar with the Airflow much. Okay, let's give a few more seconds.
And I will say that we're split in the middle exactly. Sure. That's very interesting. 50-50 with people that heard of lakeFS and didn't hear about lakeFS. So we probably want to somewhat explain some basic functionality of lakeFS when we go through this as well.
Okay. And I see Airflow, like about 60, 70% people know Airflow, 60%. So I'll not go too much deep into Airflow. I'll keep it a little high level on the Airflow side. And we can do another session or one-on-one if you want to go into more details or in-depth. Okay, so let me share my screen now. Okay, so either talked about the demo environment, just quickly show you, like once you install our sample repository, it will create a Docker container. So this is the container I'm running, and that container includes everything for the demo except lakeFS. lakeFS I'm running here also in a separate container, but you can use lakeFS Playground or lakeFS Cloud, whatever you prefer to run lakeFS, you can choose. But for the sample, it's just a single container which includes Airflow, Spark, Python, anything required for this demo is bundled in single container. Okay, so now let's switch over here. So first, as only 50% people know about lakeFS. So first, I'll just walk through quickly on the lakeFS side, and then I'll go into more into Airflow. So lakeFS is very similar to like Git kind of repositories. So here, currently I have these two repositories, which I'm going to use for demo today. Running your existing DAG in isolation to your production data set, and also running in the new DAG, which has a lot more functionality built in for data lineage, tracking, troubleshooting, and then I'll go into more details on that. So you can create the repository from here. You can create the repository using Python API. So right now I already have these created through the API. So let's look into one of the repository. So when you go into the repository, you can see all the objects that are part of this repository right now. So I have in this case a main branch, which is my production branch. You can name it master branch, production branch, whatever you want to call it, you can name that, but as your main branch. And then you can upload the objects into this repository. You can upload the object one by one or in a bulk, or you can do import, where when you import, it's not going to copy all the objects into the repository. It will just have a pointer to your existing objects. So let's say you have millions of objects already there in your object store, in S3 bucket or in blob storage. And when you import, we are just going to import the metadata about those objects. We are not going to import all the data set. Let's say you have terabytes or petabytes of data. We are not going to import the petabytes of data. We're just going to bring the metadata for those objects. And we maintain just the pointers to those objects. So when you create the repository for the first time, to import millions of objects might take a couple of seconds only to import everything. Again, we are not importing the data. We are just importing the metadata for those objects. So that's how you will set up the repository initially. For the demo in the notebook, I have everything, so you don't have to do anything manually. Everything you'll do through that notebook. And then here you can create the different branches. You can create the branch from UI, or you can create from the Python API, or through our operator for Airflow that I mentioned earlier. There's a create branch operator. So from the DAG itself, using the operator, you can create those branches. So like, for example, in this case, this branch was created through a DAG using the operator. And then, and also when you make any changes in your data set through that DAG, instead of uploading those changes or committing those changes in the main production branch, you are going to commit in the separate branch. So you are running basically your DAG or your data transformation in isolation to your production environment in a separate branch. And then you'll commit all those changes within that branch only. So let's say you have multiple step process. So after each step, you can commit those changes into that isolated branch. once you are done, then you can merge those changes into your main production branch. So once you merge, or you can see all the commit history, all the changes that you made. Like for example, in this main branch, I created this repository first, and then I made my first commit, and then merged my the DAG changes into my production. As Ido mentioned earlier, it's when we merge the changes, it's atomic merge. So let's say in your DAG, you changed thousands of files. There are a lot of new files came in, you deleted some files, you changed a lot of files. When you merge into the main production branch, it happens atomically. So all the changes merge into production all together in a single command and millisecond operation. So that's kind of high level overview of what lakeFS is. Now let's look into quickly this sample repository. So as Edo mentioned earlier, this sample repository includes everything required for this demo, including Airflow and Python and Spark. And there are multiple notebooks here. Today we are going to focus on 2 notebooks. And it's very easy to clone this repository and then run this container locally. In this case, as I mentioned earlier, I'm running this container locally. Now, next, look into the Jupyter environment. Anything else, Ido, you want to add?
Yeah, just as you pause for air, I will go back to the branching, and you called that out, but I think it's really important to call out also for those of you that have not seen lakeFS before. lakeFS enables zero clone copy, basically. So when I create multiple branches in my environment, that's without copying the data. And since the object store is immutable, we basically do copy and write. We don't want to spend too much time in this webinar to explain how that works, but if anybody has any questions about understanding that in more details, then please go ahead and reach out. Or if you want to have additional specific questions about that, you're more than welcome to post here as well.
Good, thank you. So once you download this repository or clone this repository and build the container and run the container, after that, you just click on this local host, this port 8888. So it will open the Jupyter Lab UI, which I have it here. And in this, you have these multiple demo notebooks. Today, I'm just going to focus on Airflow notebooks. There are 4 Airflow notebooks here. One is running your existing DAG, and I'll go and talk more about that. And then running the new DAGs with additional stuff, more advanced features, and then running hooks, lakeFS hooks, along with Airflow, and also doing the DAG versioning. And I'll talk more about each of these notebooks. So with that, let's start with the existing DAG notebook. So it provides all the instructions here, how to get started with this notebook. And as I mentioned earlier, for repository and everything, you don't have to do anything manually. Everything is built in this notebook. So here, you'll provide the connection to your lakeFS server. So in this case, I'm running this lakeFS server locally in my another Docker container, which is this one. So just provide the access key and credentials to lakeFS server. If you're using Playground, then you'll have a URL to go to the Playground here, and then the access key and secret key for your lakeFS Playground are similarly with the cloud if you are using lakeFS Cloud. Then you specify your repository name. So as I mentioned, I already have those 2 repositories, the branch name, your main branch, production branch, and the new branch we are going to create for this demos. And then also storage namespace. In this case, I'm using repository stored locally in my local Docker container, but you can point it to your S3 bucket or any object store you're using, Blob or Azure Blob or Google Cloud Storage. It can point to that where the lakeFS repository will be stored. So there are 2 kind of buckets you will have. One bucket, one object store for storing the lakeFS metadata, and another one where you have your own data set currently, which can be in this separate bucket which you can import into lakeFS. Again, when you're importing, we are not copying the data. We are just importing the metadata. And any new file you upload into lakeFS goes into this bucket. And then you just run the lakeFS. So, Airflow, and there are some setup required for Airflow. So that's you run it here, and then you create the repository. Again, everything is built in this notebook. So you just create the repository, and then you trigger your DAG. So let's talk about how that piece works. So let me switch over here. So let's say now let's go into more detail on how we integrate lakeFS and Airflow together. So the first use case is if you have an existing DAG, how can you quickly integrate with lakeFS and run your DAG in isolation to your production data set? So this is, let's say, my production branch or production my data lake. And I want to run my DAG in isolation. So I'll create a separate branch. And as I either mentioned earlier, when we create a branch, we are not copying all the production data. It's just the metadata operation. So when you create a new branch, it's a millisecond operation. And in that branch, we have pointers to all those data files which are part of production. But we are not going to change those files, just we have the pointers. And then you run the DAG in isolation. If you make any changes in your DAG, if you make any changes for the data in your DAG, we are going to keep that in a separate data file in this isolated branch. So we are not going to change anything in your production data set. Everything will remain in isolation. And once your DAG is done, everything is successful, then you'll commit your changes. And after the committing, when you are satisfied everything, all your data quality checks, everything is done, then you'll merge everything into your main production branch. And as we mentioned earlier, it's atomic merge. What that means is, let's say in your DAG, you change thousands of files. When you merge into production, it's a single command operation, first of all, and then it will merge all 1,000 files into production instantaneously. So as soon as your ingestion process or that DAG execution process is done, you promote everything instantaneously to your production. So your users will be able to see everything instantaneously. Traditionally, what people do is like people run DAG in the production environment, or they might create some staging environment by copying some data set. But you might have only half of data available in production. But in our case, you do atomic promotion, so everything is available instantaneously. So that's the first use case. So let's look into, yeah. Anything else you want to add? No,
I think there's two huge elements to this. One is which you called out. One is if you have a long running DAG, then it doesn't matter, right? There's no half tables that are already modified in production and things like that. So you keep your data lake consistent. And the other one is not to say that, my DAGs never fail, but if you have a 4-hour DAG that fails after 3 hours, then nothing was exposed, right? You don't need to try and roll back changes midway, and you still have the context of the failed DAG in the DAG execution branch that you can go and investigate it. So you're really winning on all sides. It's literally having the cake and eating it too.
Yeah. So for this use case, again, you'll just follow this notebook and run this, trigger this DAG. So let's look into that DAG here. So this is my DAG here. So let's say you have existing DAG. So what we provide is in this code is the wrapper DAG. So which will wrap your existing DAG around. Like first, so we'll create the branch in lakeFS using the lakeFS operator. Then you'll trigger your existing DAG, and I'll go into more detail on that. And then once your DAG finishes, you'll commit all your changes. When you're committing into this new branch, not in the production branch. You're committing to the new ETL branch. And after that, you can do all the quality checks and everything. you can do those checks using lakeFS hooks if you want, and then merge all your changes into production. So that's how this DAG looks like. So let's look into the code. Let's go into more details here. So first thing doing here is call this create branch operator, lakeFS operator, where we are creating a new branch. Let me increase the font size. So create the ETL branch and then trigger your existing DAG. So for this demo, we are using this tutorial DAG, which comes with Airflow. So if you install Airflow with tutorials, with examples, this tutorial is included. So we are using the same existing tutorial DAG with some minor modifications. I'll show that. And then once the DAG is finished, you run the commit operator, you commit your changes into that new ETL branch. And once everything is satisfied, then you can merge those changes into production branch using our lakeFS merge operator. So this is more simple, easy to kind of use integration use case where you can integrate both lakeFS and Airflow very quickly. So let's talk about going to trigger this existing DAG. So I mentioned earlier, like make a small change in this existing DAG. So let's look into that DAG. So as I mentioned earlier, like this is the existing DAG, which comes as a tutorial with Airflow. So it does some extraction, transformation, and loading. So let's quickly look into the code here. So if you have used this tutorial DAG with Airflow, then it's very simple DAG. It does some extraction. It just creates a sample data set here. Then it does some transformation. In this case, it's a number of orders with the order amount. So it does the total order value, and then it writes to a file. So, or in this case, it just prints the order value in this load operation or load task. But what I added here is a small code here to write data to lakeFS. Why we are doing this is so we can version control, or we can track all those things in lakeFS. So when you're writing, you specify repository name, the branch you want to write to. Again, in this case, I'm writing to the new branch. I'm not writing to the main branch. I'm writing to the ETL branch and uploading my object to my ETL branch in this file. So that's a small change you will do in your existing DAG. Whenever you're writing your data to your data lake, let's say your object store, instead of writing directly, you will write through lakeFS, so we can keep track of that, all the changes that are happening. So that's the simple change you will make in your existing DAG. Anything else you want to add about this use case before I go to next, Ido?
No, just maybe for the people that are maybe not familiar with Airflow, when you look at a DAG, obviously the green squares or frames basically represent actions that were executed successfully. Those are successful actions. Just for the sake of those of you, the almost 40% that are not familiar with Airflow on this call.
Good, yeah. Okay, so now let's look into the next use case. So the next one is you have your existing DAG, but you want to add more lakeFS operators or more integration with lakeFS so you can do better tracking of all the changes which are happening. So data lineage. Even in this case, you're running your DAG in isolation from your production environment. But after each task, let's say you have a DAG which has multiple steps, thousands of steps, you can commit your changes into this new branch in lakeFS. So let's say you changed one data file or two data files, then you commit your change. And then so on, like after each task, after each data changes, you commit your changes. That way, you have full data lineage. You can track if something fails, let's say here, you can go back and start traversing back and see what changes happen in your data in each step. And that you can track easily in lakeFS, because we have, similar to Git, we have comparison of operation here. Like you can compare two different branches and see what changed between one commit to another commit. So in this case, so basically you'll compare, let's say your DAG failed here, a task failed here. So you'll compare this DAG to the previous commit, and compare this commit to a previous commit. So you can see what are the changes happening over time as the DAG execution is going on. That helps you for troubleshooting on the troubleshooting side. So let's say if something fails, you can easily traverse back, see the data lineage, and easily troubleshoot your problems. So I'll show you in this example. So again, for this, use this, it's called this Airflow demo new DAG notebook. So let's open that one. Again, here, just simple setup steps. Here, you provide the credential to connect to lakeFS server, your repository name, the version information, and your storage information, which I mentioned earlier, and then continue following each step at a time in this notebook. So what this will do is once you run this this notebook, first it will run this DAG. It will create this Airflow DAG, and then it will trigger also. So let's talk more about this one. So here we are still doing a similar kind of ETL job. So here you'll see some of the ETL tasks here, like loading your data file, and then running some of the tasks. In this case, what I'm doing is partitioning the data. So I received the data file. I'm going to partition using a Spark on different columns. So those are the tasks I'm running here in these task box. But I added more integration with lakeFS so that we can keep track of all the changes happening. So after each, here, for example, I created a separate ETL branch, and then I created this separate branch again for loading my data. I load my file, I commit my changes. So let's say 5 data files came in, I then commit my changes. And then I create a separate branches to run my different operations in parallel. Let's say you have existing DAG where you are running things in parallel, but there are some tasks are sequential, some tasks are parallel you can run. So you can run those parallel tasks in a different branch without impacting the other branches. And then after each task you finish, you commit your changes. So that way we have full tracking capability, full data lineage capability. If something goes wrong, you can easily track. And then once your task is done, you merge your changes into the ETL branch, and then finally you merge your changes into your production environment. Here, there is an example for using our sensors also. Earlier I mentioned about we provide sensors as part of our provider for Airflow. So here, for example, you are sensing a file. So let's say as soon as you upload your data file, the new data file comes in, you are looking for that, sensing for that file. So as soon as that happens, you can perform some operation, like maybe data quality checks or something you want to do as soon as the file lands in lakeFS. And in this case, I'm just getting the file and doing the data check, like whether my data matches with the file or not. Similarly, we have a sensor for commit. So if any commit happens, you can sense for that commit and do certain operation. In this case, once my final commit is done, then I'm merging it to my production branch. So that's the usage of the sensors. So like this DAG, in the notebook, you'll see when you run this DAG through notebook, everything is successful. But if you continue in this notebook, let's say if you receive the new latest file, new data file, and run the DAG again, trigger the DAG again, at the time, this file has some bad data. I'll talk about that. So that DAG is going to fail. And now I want to show how it will help you in troubleshooting the problem if DAG fails. So the same DAG which I talked earlier, in this case, all the green boxes, everything went successfully, but in this case, this task failed. As I mentioned earlier, this is in this task, we are just partitioning some data. So we can quickly look into the code here, what it is doing. So again, in this code, you can go into more detail later on, but here I'm creating the branches using the operator, and I'll go to the task very quickly here. So these are merge operations. 1 second, let me find that task. Okay, here it is. So in this case, I'm using a Spark submit operator, and in this, all is these tasks, and in these tasks, what they are doing is just partitioning my data. So let's look into like what happened to this failed task. So first thing I want to look into how my data is changing, evolving from one step to a next step. So I'll go to my previous step and try to trace back the changes. So click on this. If I click on this tag, so you'll see it will. We added this button here to take you directly to lakeFS UI. So what was the state of your data at that time? It will take you directly to in lakeFS. This is using if you are familiar with Airflow, this is using the Airflow plugins, and that code is also included in this demo environment. So let's go to lakeFS UI. So what this will do is it will take me to the location or to the state of the data that happened before the task failed. So in this case, basically it takes me to the previous commit when the branch was created. And it tells me what data changes happened. So in this case, there was this new file came in, the new data file came in. So anytime and if it is green, that means a new file. If it is red, that the file was deleted. So you can see all the changes happening in lakeFS. We keep track of all the changes. So in this case, this new file came in, and you can also see the changes in the file. So let's say if the new file, there was only one record in this case, and it has only 4 values or 4 columns in here. So it will show you all the changes that happened in your data file. If it is a readable file, like a CSV or text file. If it is a Parquet, it will not show you the changes exactly, but it will tell you the Parquet file changed, but not the exact change inside the Parquet file. So now,
Amit, sorry to interrupt. There's also a question on the Q&A. If we can do the other way around, like, can you go to a data set and then see? Because you just showed how you went to a task ID and saw the data set at the time of that task ID, but can you go to a data set, after it is finished and see what task executed it the other way around, which is like I think is another different troubleshoot that we didn't think of, which is also interesting.
Yep. So like, for example, you can go into objects section in lakeFS, and in any branch, you can select any branch here and see, let's say, for example, in this branch, I have this data file, and I want to see where this data came from. So here we have some functionality called blame functionality, which is very similar to you have familiar with in Git, which in the blame functionality will tell you where this data came from. Like, for example, this CSV file came through this commit, and it came from Airflow, committed from the Airflow DAG. And also like who committed on all the metadata information about that. So whenever you commit your data, you can include as much metadata as you want. In this case, this file came through this commit data load task from Airflow task, and by committed through an operator in this case. But you can include,
that's awesome.
Yeah, you can include the version number, the code, like Git repository link, whatever metadata you want to associate when you commit your changes or commit your data, you can include that here.
Right, and you can do the same for a data set also. It doesn't have to be a file. So I can do the same for the partition data underscore C1, for example. Yeah.
Correct. Yeah.
Perfect.
In this case,
Thank you.
in this case, this came from the task one that, so this will again provide the full kind of lineage, how the data is coming through, what changes are happening, where it is coming from, all the metadata behind this.
Thank you.
Okay. So now, so we saw that just before this DAG failed, what was the state of the data? Like what changes changed? Like in this case, a new latest CSV file came in, which has just 4 columns in there. And now let's go into this failed task and look for the log for this. Now let me just search for exception. So as I mentioned earlier, this task is basically partitioning this data file by columns. So in this case, looks like what happened is in this file is trying to partition by 5th column, like a column 0 to 4, which is 4th column is 5th column here. And the 5th column was not there in that data file. As you saw earlier, there were only 4 columns in that data file, 1, 2, 3, 4, and the 5th column is missing. That's why it failed. So that's where we help you to troubleshoot the problem. Otherwise, without lakeFS, you have to go back and look into where the changes, like manually trying to figure out on your own. While we take you directly to where the problem is, we tell you all the changes that happened in previously in your data files, so you can easily, quickly troubleshoot your problem. Okay. Anything else you want to add on this use case before I go to the next two? And I'll just talk very high level for those 2 use cases.
Yeah, no, I think this is fantastic. I think that's literally the exact problem that we started with. And these are good ways for you guys. We have the notebooks, they're available. I'll share those at the end with links again for everybody. But let's just review what is the next 2 ones just for the sake of time. And again, you have notebooks that you can see those step by step.
Yep. So for this one, this is the notebook you can use, which is the Hooks Airflow demo. In this, what we are doing is we are doing all the validation using lakeFS hooks. If you are familiar with the Git actions or Git hooks, it's a similar kind of concept. So here, again, I create the separate ingestion branch, and then I add my data and commit my data. But after I commit it, it will automatically invoke the Airflow DAG to run some transformations, for example. So it's all fully automated. It's like implementing your CI/CD process. As soon as data comes in and you commit, it will automatically trigger your DAG. And then it will, in a separate branch here, it will do all the transformation. And then after the DAG is successful, this will create a success file. So when you try to merge your production, all the changes atomically into production branch, it will call another hook or another DAG, which will look for this success file. If the success file is not there, it will not let you merge your changes into production. So what it helps is, like, you can do lots of validations before you merge your changes into production. So those validation can be done in a separate within a DAG, or you can use any third-party tool to do your data quality checks. And once that is successful, then you create a success file, and you will be allowed to merge only once everything is successful. And the next use case is code plus data versioning together. It's much more advanced concept. Once you start using Airflow, you'll see that you would like to do the version control of your DAG also, like similar to like Git code. So lakeFS provides data versioning, but here we are providing both code as well as data versioning together. So let's say you have production, your main branch, then you'll have a DAG for that branch. But when you create a new branch, we'll automatically create a new DAG for that particular branch. In this case, let's say if I'm creating a new version of my code. So I create a new version branch. What it does is this hook will automatically pull your code from Git repository. Again, this is not data, this is just the code. We get the DAG template or DAG code from the Git repository, and then create a new DAG for this new version. So now you have isolated environment for your data as well as for your code. So you have a new DAG for new version as well as the data for the new version. So the full code plus data versioning and isolation from your production. Then you can run whatever process you want to run, the changes you want to make in your DAG. Again, this is a separate DAGs, so you are not impacting your production DAG. It's all isolated environment for code as well as data. And then once you are done with all the transformation and everything looks good, and you want to merge your changes into production, you can do merge directly. But if you're not satisfied, if things doesn't look good or something went wrong, you can delete this branch. And when you delete the branch, behind the scene, it will automatically delete your version DAG, the new version DAG also. So that way you are not impacting anything, your production data or production DAG. Everything is in isolation in a separate environment. Again, this is the notebook here included, which is DAG versioning. You can follow through and run this demo also on your own. Or if you're interested, you can go into more details how it is done.
Sorry, yeah, and I think, I mean, I'll take the screen, and maybe if you can help me ask the last question exactly about that, which is if anybody's interested, like if you guys are interested, this is basically the question that we want to ask in us to learn more and continue to learn about this topic. We're happy to have some follow-up webinars to review these in more details and maybe with like a hands-on kind of approach. If you're interested, feel free to let us know. I want to share some useful links with you guys, just generally speaking. Before I do that, I hope what you learned today is how lakeFS helps you reduce your storage, as I have multiple DAGs running in concurrency without ever copying the data, how it enables data engineering best practices and efficiency in terms of creating CI/CD for your pipeline and troubleshooting easily and so on and so forth, and how you will never ever have to manually chase a production issue under fire, because everything is done in isolation. And even if something happened, we can always roll back to our last version of the data, because everything is versioned throughout the execution along the way. lakeFS is available. lakeFS is available as an open source. Actually, everything that you saw today is available on the open source solution, which is also, I think, very important and powerful. So we subscribe to the open core approach, meaning the full integration, the full scalability is available through the open source solution. And of course, we have a hosted enterprise solution where we host it, we patch it, we maintain it, and we also provide some enterprise features such as single sign-on and role-based access control and audit logs and things like that. And if you can't take advantage of the cloud, then we also allow you to use our enterprise solution. I see someone just joined. So for those of you that just joined, we're about to wrap up, but we'll send over the recording of this webinar, as well as a few other links that I think can be very useful. One, we have a community Slack, super resourceful, very active, lots of questions there is daily. I encourage everybody to join the community Slack and ask questions if you want to get some hands-on experience with lakeFS. Two, we have a lakeFS Playground. I presented this as one of the 3 ways to get a lakeFS server running. This is basically a way to click a button and then get the lakeFS environment up and running and experiment with that. And third, all the 4 notebooks that we reviewed here today are available for you throughout through the sample repositories that you can try those on hands-on. You can do that against the Playground if you wanted to. At this point in time, I just want to pause a little bit and see if anybody has any last-minute questions above the ones that were asked throughout this webinar. I'll give this 1 minute to see if people have additional questions. Going once, going twice. By the way, I will share with you, Amit, I don't know if you read it, that we got 100% yes of would you like to learn more about this topic. I think this is the first. So Amit and I will probably work on creating some sort of more detailed series that will continue reviewing this for you guys. Thank you, everybody. Thank you, Amit, for the major heavy lifting here on this webinar.
No problem. Yeah, we covered a lot today. So if you guys are interested to go into more deep on the code, how we did all the coding behind this, let us know.
Yeah, and Amit and I are both on Slack. So if you join the Slack, feel free to reach out. Happy to help. Thanks, everybody. Wait, anonymous attendee said thank you. You're very welcome. Anonymous attender, so attendee. So thank you guys. Have a wonderful rest of your week. And thanks, Amit. Back to you later.
Bye-bye.
Bye-bye.